I'm going to review the concepts from Module 3 before you guys take your tests. So in Section 1, we talked about whether or not something was a polynomial. So remember, in figuring out if something is a polynomial, you look at what the variable can't be. So just in general, a variable has to have all positive whole number exponents. So if we're looking at a, x to the fifth minus 5x plus 4. All of our variables have exponents that are positive and whole numbers, so this one is a polynomial. Okay. But in B, we have this cube root x. So we have cube root x plus x squared plus 3x. And that cube root means that it is not a polynomial. So just a couple reminders. So exponents cannot be negative or a fraction. Okay. No roots and no variable in denominator of fraction. So those are the three things you can't have for something to not be a polynomial. If any of those things appear with a variable, these are specific to variables, then it's not a polynomial. So the next thing we looked at was ascending and descending order. So ascending order is putting something from lowest degree to highest degree, and then descending order is from highest degree to lowest degree. So when I'm picking out in my expression negative 6x minus 4 plus 3x squared plus x cubed, I start with my highest exponent, which is x cubed, and then I work my way down. So then after x cubed become x squared, so we have 3x squared. Then would come x, and we have our negative 6x, and then lastly our constant negative 4. So when you're putting something in ascending or descending order, you're not listing the terms, you're actually writing the expression. So you got to make sure to include pluses and minuses. Section 2, we were doing operations with polynomials, specifically addition, subtraction, and multiplication. So the first example is addition. So we have 3x squared minus 4x plus 1 plus x cubed minus 6x squared minus x plus 4. So when you're adding polynomials, you can just ignore the parentheses and combine like terms. So we start with I always start with the greatest degree, which this case is x cubed. It doesn't have a like term, so it stays x cubed. Then working my way down would be x squared, and there's a 3x squared and a negative 6x squared. 3 minus 6 is going to give us negative 3x squared. And then we have our x terms. So you have negative 4x minus x, which gives us negative 5x. And then lastly, we have 1 plus 4, which is 5. Okay. 4, we have the exact same expressions, but now we're subtracting them. So before we combine like terms, I always distribute the negative into the second set of parentheses so I can just combine like terms. So when I distribute the negative, it becomes 3x squared minus 4x plus 1 minus x cubed plus 6x squared plus x minus 4. And now I combine like terms just like I did in number 3. So the negative x cubed still doesn't have a like term. Then it's 3x squared plus 6x squared, which is 9x squared. Then it's negative 4x plus x, which is negative 3x. And then 1 minus 4, which is negative 3. So because we did this with the same two problems, it's easy to see how addition and subtraction don't result in the same answers. None of our terms are the same, so it does matter with addition and subtraction. Okay. Next, we're going to take a look at multiplication. So we're going to multiply x plus 1 times x cubed plus 3x squared minus x plus 8. So when we multiply, everything in the first set of parentheses is going to multiply to everything in the second set of parentheses. So I'm going to take that x and multiply it to all of my terms. So x times x cubed is x to the 4th. Because remember, when we multiply, we add exponents. And there's an invisible 1 in the exponent of the x. And then x times 3x squared is 3x cubed. X times negative x is negative x squared. And x times 8 is 8x. Now we're going to do the same thing with the 1. We're going to multiply it to everything. So 1 times x cubed is x cubed. 1 times 3x squared is 3x squared. 1 times negative x is negative x. And 1 times 8 is 8. Now I want to go through and look for any like terms. So x to the 4th doesn't have a like term, so it says x to the 4th. We have 3x cubed and x cubed, which becomes 4x cubed. Negative x squared plus 3x squared, which is negative 5x squared. Then we have 8x minus x, which is 7x. And then we have our plus 8. So remember, when we are adding like terms with variables, the exponents don't change. Okay. Next, we have 4xy cubed times 2x minus 12. And I rewrote it so I could draw the lines to distribute. So 4xy cubed is one term that we're going to multiply into our parentheses. So when we multiply numbers and we multiply variables. So 4 times 2 is 8. X times x is x squared. And there's nothing for the y cubed to multiply with, so it stays y cubed. Then we have minus 12 times 4, which is 48. And the variables don't have anything to multiply with, so it stays xy cubed. Remainder is 3. In section 3, we talked about division. So long and synthetic division. And I'm going to do an example of each. And then on the test, so that you may be asked to specifically use long division, you may be specifically asked to use synthetic. It may be up to you, so you could just choose the method that you prefer. So our first example is x cubed minus 4x plus 6 divided by x minus 1. And this is the example I'm going to do with long division because it's a shorter polynomial. So when we set up long division, what we're dividing by goes on the outside, what we're dividing goes underneath. Now, because I'm missing my x squared term, I want to account for that by putting a 0x squared. And then minus 4x plus 6. So when I'm doing long division, I always divide the x's. Okay, so I'm going to do x cubed divided by x, and that's going to give me x squared. Now I want to multiply x squared by what we're dividing, x minus 1. So x squared times x is x cubed. X squared times negative 1 is negative x squared. Then we're going to subtract that from what we have underneath. So x cubed minus x cubed cancels. And this is why I put the 0x squared in there, because I have 0x squared minus a negative x squared, which becomes addition when we subtract a negative, so it becomes x squared. Then we bring down our other two terms, so minus 4x plus 6. Now I'm going to divide again. X squared divided by x is just x. So now I multiply. X times x is x squared. X times negative 1 is negative x. Then we subtract. X squared minus x squared cancels. Negative 4x minus a negative x changes to addition. So it's negative 4x plus x, which is negative 3x. Then we bring down our 6. Then we divide again. Negative 3x divided by x is negative 3. then we multiply. Negative 3 times x is negative 3x. Negative 3 times negative 1 is positive 3. And then we subtract. Our x's cancels, and then 6 minus 3 is 3. So my final answer is x squared plus x minus 3 plus our remainder 3 over what we divided by x minus 1. Next, I'm going to do an example with synthetic division. So synthetic division is, in my opinion, best used anytime you're not dividing a x squared polynomial by anything. But I realize that not all people like synthetic division. So when we set up synthetic division, we have to figure out what number is going in the box. So we take what we're dividing by, x minus 4, set it equal to 0, and solve. So we get x equals 4. So 4 is going to go in our box. Then we put all of the coefficients across the top. So we have 2x to the 4th, and then we have to make sure we account for every possible term in decreasing variables. So then an x cubed, which we have, so negative 9, x squared, which we have, negative 21, x, which we have, 88, and a constant, which we have, 48. I always separate the last two terms. That way I can easily identify my remainder. So we always bring down the first coefficient to the bottom. Okay. Now we multiply it by the number in the box. So 2 times 4 is 8. And we add going down. So negative 9 plus 8 is negative 1. Now we multiply again. Negative 1 times 4 is negative 4. Adding, we get negative 25. Negative 25 times 4 is negative 100. Adding, we get negative 12. Negative 12 times 4 is negative 48. And adding, we get 0. So remember, the reason why we separate the last two terms is so we can identify a remainder. So we have a remainder of 0 here. And then we start with our first term as our constant and then work our way up in exponents. So constant x, x squared, x cubed. These numbers are now the coefficients of my answer. So we have 2x cubed, a negative 1x squared, negative 25x, and negative 12. And because my remainder is 0, I don't have to write anything for my remainder. Section 4, we were factoring. So this there were a lot of different factoring that we did. We factored polynomials with a leading coefficient of 1, greater than 1, GCF, difference of squares, and sum and difference of cubes. So our first example is x squared minus 6x minus 40. So we have a leading coefficient of 1. So anytime our leading coefficient is 1, we look for the numbers that multiply to c, which in this case is negative 40, and add to b, which in this case is negative 6. So if I start thinking, the only way to multiply to a negative is to have one positive number and one negative number. And we want to add to a negative, which means the numbers I'm looking for, the bigger number is negative. So if I think two numbers that multiply to 40, negative 20 and 2, which don't add to 6, and then negative 10 and 4, those do. Negative 10 plus 4 is 6. So in my parentheses, we're going to have x minus 10 and x plus 4. And again, you could have written your parentheses the opposite way, where it was x plus 4 and then x minus 10. Next, we have 8x squared minus 32. So typically, anytime you have a squared variable minus, I tell you to look for difference of squares. But 8 and 32 are not perfect squares. So next, I look for a GCF, so something that goes into 8 and 32. And 8 actually goes into both of those. So I'm going to factor out my GCF of 8, and that leaves me with x squared minus 4. So now x squared and 4 are perfect squares. So because x times x is x squared and 2 times 2 is 4. So when I factor it, I still have my 8 for my GCF, and then one set of parentheses is x plus 2, and my other set of parentheses is x minus 2. Again, you could have written that as x8 times x minus 2, x plus 2. Next we have 10x to the 4th plus 20x cubed plus 10x squared. So if I look here, I look at all my numbers, 10 goes into 10, 20, and 10. So I know I have a GCF of 10. I also have an x to the 4th, an x cubed, and an x squared. So every term also has an x, and there are actually 2 of them that every single term has in common. So I know I have a GCF of 10x squared. And when I factor out my GCF of 10x squared, I'm left with x squared plus 2x plus 1 in my parentheses. So now inside my parentheses, it becomes just like a. I'm looking for the numbers that multiply to 1 but add to 2. There's only one way to multiply to 1, which is 1 times 1, and 1 plus 1 is 2. So we're going to have 10x squared, and then inside both of our parentheses, we're going to have x plus 1. So in D, we have 21x squared plus 25x minus 4. So the number in front of x squared is greater than 1. So I typically always look for GCF. And there is no number that goes into 21, 25, and 4. So I'm going to have to use the box method to factor here. So when I set up my box, my x squared term goes in the top left, and my constant goes in the bottom right. So when I'm looking for my numbers, I have to do a times c first, because there are no multiples of negative 4 that add to 25. So now when I do 21 times negative 4, I'm going to get negative 84. So I'm looking for 2 numbers that multiply to negative 84 but add to 25. So the only way to multiply to a negative is to have one positive number and one negative number. And because we're adding to a positive, I know the smaller number is negative. So I'm going to start with the 2 numbers I multiplied, 21 and negative 4, which do not add to 25. So let's try 84 divided by 2. So that's 42 and negative 2, which do not add to 25. Let's try 3. So 28 and negative 3 multiply to negative 48, and 28 minus 3 is 25. So those are my 2 numbers. So we're going to put a 28x and a negative 3x in our 2 boxes. It doesn't matter which box you put them in. So now, each row, we're looking for our GCFs. So 21x squared and 28x. Well, both of them have an x, and 7 goes into both of those numbers. Okay. Next, we're going to look at negative 3x and negative 4. So both of them are negative, so I know I can bring out a negative, but there's no number that goes into 3 and 4, so I'm just going to use negative 1. Okay. Now we're going to look at our columns. So 21x squared and negative 3x. They both have an x, and 3 goes into both of them. And then 28x and 4 goes into both of those. And this one's going to be positive. So remember, when you're trying to figure out whether or not your constant is a positive or negative that you factor out, it's always the same as the sign of the x term. So because 28x was positive, my GCF was positive. And because negative 3x was negative, my GCF was negative. So now the row is a set of parentheses and the column. So we have 7x minus 1 in a set of parentheses and 3x plus 4 in the other. And again, you could have written it as 3x plus 4 first and then the 7x minus 1. Okay. Next we have 27y cubed minus 8. So because we have a cubed variable, I know I'm going to use my sum or difference of cubes formula here. And it's going to be difference because we're subtracting. So I need to figure out what cubed gives me each of these terms. So cubed means multiplied by itself 3 times. So in order to get 27y cubed, I have to do 3y cubed, because 3 times 3 times 3 is 27, and y times y times y is y cubed. And then in order to get 8, we do 2 cubed, 2 times 2 times 2. So in the first set of parentheses, I'm going to subtract my cube roots. So it's always the first one minus the second one, so 3y minus 2. Then I want to square my first term, so 3y squared. I have to square the 3 and the y, so we're going to get 9y squared. And then plus, now I'm going to multiply them together, so 3y times 2 is 6y. And then plus, and then we want to square our second cube root, so 2 squared, which is 4. And again, this equation is in your 3.4 notes. If you haven't filled out those notes yet and written down your sum and difference of cubes formulas, I definitely would. And then we have x squared minus 12x plus 32. So we're going back to just like it was in A, where my leading coefficient is 1. So in this case, I'm looking for the numbers that multiply to 32 and add to negative 12. So the only way to multiply to a positive number and add to a negative number is if both of them are negative. So I know negative 2 and negative 16 multiply to 32, but those don't add to negative 12. Negative 4 times negative 8, which does add to negative 12. So I know those are my 2 terms. So an x minus 4 and an x minus 8, which you could have written the other way as x minus 4, x minus 8. Doesn't matter. So next in section 5, we talked about rewriting roots. So we have 4 to the 5 halves. So when we're looking at fractional exponents, the numerator of the fraction is the power you're raising something to, and the denominator is the root you're taking. So a root of 2 is a square root, so I'm taking the square root of 4, and then I'm raising it to the 5th power. And it doesn't matter the order in which you do things. I can raise 4 to the 5th power first, and then take the square root. But in this case, it's going to be easier to take the square root of 4 and then raise it to the 5th power. So the square root of 4 is 2, and I want to do 2 to the 5th power, which is 32. So remember, raising something to a power is multiplying by itself that many times. So 2 times 2 times 2 times 2 times 2. You can also use a calculator for raising things to fractional exponents, but you also want to be able to rewrite it in radical form before doing so. Okay. So section 6, we took at simplifying radicals and adding and subtracting. We also talked a little bit about multiplication. So when simplifying a radical, like in A, the square root of 63, we'll start breaking it down into 2 numbers that multiply to 63. So I know 63 can be divided by 3, so 3 and 21. And 21 is 3 times 7. And 7 is prime, so I can't break that down anymore. So square root means I have to have a pair of something in order for it to come outside my radical. So I have a pair of 3's, so it's going to be 3, and then underneath the radical, still have my 7 since it was alone, it had no pair. B, we have the cube root of 125 a squared b to the 5th. So we're going to break down 125. It's 5 and 25, and 25 is 5 and 5. So because it's a cube root, we have to have 3 of something, and I have exactly 3 5s. Okay. Next, we're going to go to our variables. So a squared is a times a, and b to the 5th is b times b times b times b times b. So with our variables, in order to bring it outside of our radical, we have to have a group of 3. We only have a squared, so there isn't a group of 3 there. But in the b's, there is a group of 3. So when I write my simplified answer, we have our 5 and we have a b, and then underneath the cube root, we didn't have any numbers left over, but we still have our 2 a's, so a squared, and we have 2 b's, b squared. I think one of the most important things to remember when you're simplifying roots that are higher than a square root is the index here. A lot of people on the section 6 assignment did not put, if the root was something other than square root, they didn't put their 3 or their 4. You have to make sure that that index is there so we know that it's a cube root and not a square root. It's extremely important that you have that there for the test if it's something other than a square root. So next we're going to look at adding and subtracting radicals. So in order to add or subtract a radical, they have to be like radicals, which means they have to be the same root and what's underneath that root has to be the same. So in C, we have 4 square root 5 minus 6 square root 5. So both my radicals are like radicals here because they're both square roots and they both have a 5 underneath. So I just subtract the numbers out in front. So 4 minus 6 is going to give us -2, and then the radical doesn't change, square root 5. Remember, I told you to kind of think of the radical as a variable. When you do 4x minus 6x, you get -2x. The x doesn't change. It's the same thing with radicals. Our next example is 3 square root 18x plus 9 square root 2x. So they are both square roots, but they don't have the same thing underneath those roots. So we want to see if one of them or both of them can simplify. So I'm going to start with the square root 18x. I know 18 is 9 times 2, and 9 breaks down as 3 and 3. So I have a group of 3's there. And when I'll bring my group of 3's outside my radical, I have to pay attention to the fact that there's already a 3 out there and multiply them together. So it's going to be 3 times 3. Then underneath, I have my leftover 2, and there aren't enough x's for us to bring any outside my radical, because I only have one x underneath, and I have to have at least 2 to bring them outside. And then my second term, square root 2x doesn't simplify, so it's going to stay 9 square root 2x. So now I'm going to do 3 times 3, which is going to give us 9 square root 2x, and then plus 9 square root 2x. So now they are like radicals, and I can just add the numbers in front. So 9 plus 9 is 18 square root 2x. So the last section went over multiplying and dividing radicals. So when we are multiplying radicals, we distribute just like we did when we were multiplying polynomials. So everything in the first set of parentheses multiplies to everything in the second. So 2 times 2 is 4. 2 times negative radical 5 is -2 radical 5. Then we do the same thing. Square root 5 times 2 is 2 square root 5. And then a positive square root 5 times a negative square root 5 is just -5. So remember, when you multiply radicals that are exactly the same, like square root 5 times square root 5, the square roots just cancel, because you end up getting square root 25, and the square root of 25 is 5. So now, -2 radical 5 plus 2 radical 5 cancels. So I'm left with 4 minus 5, which is -1. So sometimes when you multiply radicals, you end up getting a numerical answer, which is perfectly okay. So our last example, we want to simplify, and we're going to rationalize the denominator. So we don't like leaving radicals in the denominator of a fraction. We don't know what it means to divide by a radical. So what we do is we multiply by its conjugate so that we can get rid of all of the radicals in the denominator. So the conjugate of the denominator is just the opposite operation. So the conjugate of 1 minus radical 3 is 1 plus radical 3, which I'm going to then put in parentheses. So now we're going to distribute. So the 12 is going to distribute to both terms. So 12 times 1 is 12, plus 12 times radical 3 is just 12 radical 3. In the denominator, we're going to distribute very similar to what we did in our previous example. So 1 times 1 is 1. 1 times radical 3 is radical 3. Negative radical 3 times 3 is negative radical 3. And then negative radical 3 times radical 3 is just 3. So our radical 3's are going to cancel. So in our numerator, we have 12 plus 12 radical 3. And in our denominator, we have 1 minus 3, which is negative 2. And then we always check to see if it can simplify. So 12, 12, and negative 2, I can simplify those. 12 divided by negative 2 is negative 6. And then 12 divided by negative 2 is negative 6 again. And then I still have my radical 3 because that can't simplify. Please let me know if you have any questions over anything from Module 3, especially the stuff from Sections 6 and 7, since I know that's what we've covered most recently. So just reach out.